Chapter 7, the exponential function. In Chapter 7a, we will want to define a new symbol called rational index. Before, we must make a revision about you have learned in Form 2 and Form 3, which is the integral index. If you have two numbers, a and b, they cannot be zero. In Form 2 and Form 3, it is the condition for the integral index. And n and m are integers. They can be positive or negative integers. If you define a to the power m, the representation on the right hand side is just you multiply the a m times. So when you do not have any power, that means the m is the 0. In Form 3, we show that it is a to the power 0 is equal to 1. It is the most important thing that when you find some expression with a number not equal to 0 and then power 0, it will be 1. So you simplify this expression first. The second one, you learned in Form 3 also, is about the negative index. If you have the writing line here, a to the power negative n, it is represented by 1 over a to the n. And this is also very important because when we have the next properties, we always change these expressions to fraction form to simplify the result. You learned in Form 2 and Form 3, there are several properties. The first one is you multiply two index, but they have the same base. What's the meaning? That means they have the same letter a here. If a is a but this one is b, you cannot make any properties without any simplification. Now if you sure that these two are same base, then according to the definition, the first expression a to the power m is the a multiply itself by n times, and then you will multiply the next term with a with m times. Totally, you can just multiply the a by n plus n time. By the definition of the index, it's just equal to a to the power m plus n. So we have the first properties about if you have two number in index form with the same base, a to the power m and a to the power n, if you multiply them together, then it will be simplified to with the same base, but the power is the sum of the two power. The next property is quite similar, but it will be replaced by the multiplication by a division. When you have two index number form here with the same base also, you can just find out this can be simplified as also terms with only one base. By the definition, the a to the power m you can place in the numerator as a multiply itself by n times, and then divided by a times itself by n times in the denominator. By cancellation, we can say that they are all together m minus n times here. Someone will ask whether if I have m is less than n, then this number is negative. What's the meaning? It's negative, that means it is 1 over the a to the power n if you have a to the power negative m, so it is acceptable. So finally, we have the conditions that properties, it is a to the power n divided by a to the power n. If they have the same base, you will simplify as the same base a, but the power is the first one minus the other. The difference power divided by the divisor power. The second properties about the integral index. The third one is when you have a number which is in the base form, and then it's also power to another integer. It can also be simplified. By the definition, we can just say that the expression inside the bracket is just like a number. So if by the definition, the power n means that this you multiply the a to the power m by itself n times. And then this a to the power m, every can be split down to every terms with the a multiply itself by n times. So totally, you can calculate that the total, they are altogether n times n times. So in this expression, you have the properties. It is a to the power m, and then power n is just equal to a to the power m times n together. It's very important because sometimes you want to change the expressions by breaking down the bracket to just form one terms with the index form. The fourth one is about if you have a two number multiplied together first and then power to an integer, you can split it as the following by the definition: AB multiply itself by n time. But you know that when you multiply a number AB times AB, this AB can be moving to all the A to the left hand side and then all the B to the right hand side. So you see that all the A are together with their altogether n A's and n B multiply in the left hand side and right hand side. So I can get the answer. The left hand side is the left part is a to the power n, and the right side is b to the power n. So we have the fourth properties. That is two number multiplied together to the power n can be split as the first with a power n and then the second one with a power n. And the properties next is about the division of two number and then power. It is quite similar to the expressions in a times b. You do it like that. The a to the power is just a number. You multiply it by n times. But you see that the numerator multiply together and then the denominator also multiply together to form the expression like this. So finally we get a to the power n, a over b to the power n is equal to a to the power n divided by b to the power n. There are many mathematics involving index. The properties is very important. If you handling them well, then you can do the problem more easy. Now we are going to the new things in this chapter about rational index. In chapter 1, you learned what is the meaning of a rational number. A rational number is just a number in a fraction form. Integer is a kind of a rational number because when you have an integer like 3, it can be written down as 3 over 1, which is a fraction. But if this is not an integer, then you will have another expression. So before we must talking about something about the following. If you solving an equation just like this, x squared is equal to a. Here x squared equal to a. If you want to solve a number, a must be greater than 0. Okay, x squared equal to a. Then we say x is the square root of a. Because it is power 2, 2 is a square, so we say it is a square root of a. If you have x to the power 3 is equal to a, in this case, the power 3 is an odd number, and a can be positive and negative. So we can say that it is about 3. 3 is the word is called a cube. So we have the sentence that I want to solve x. X is the cube root of a. And for the next one, x to the power 4. 4 is an even number, so a must be positive. So then when we want to calculate the root of this one, we say because it's power 4, so we say x is the fourth root of a. So when you're doing your problem with a simple expression like the following, x to the power n equal to a, if n is an odd number, a can be positive and negative. But if n is an even number, a must be positive. It is very important. Then, according to the expression in the previous one, when there's 2, we say is square root, 3 is we say cube root, and 4 we say the fourth root. So if this is power n, we say it is the nth root. In order to write down it more clearly, we're using the symbol. This is called the radical sign, just like the square root you learned before, square root 2. But when you have the square root 2, this n can be omitted by the 2. You need not to write 2. But if you have a power 3, you must write down this is the cube root. And here is the root, the n root of a number. Now let's show some example. The following is the number, you know that 1000, you know that it must be a number with power 3. So according to the definition, this is the x is here, and a is 1000. So x to the power 3 is equal to 1000. So you think about what is the value of x with power 3 will be 1000. And then the other one, negative 1000, it is also power 3. But you see that here you want to have the a is a negative number equal to x to the power 3. Similarly, you have a number, the a is a negative number, and this is a to the power 3. So you can find out the cube root of the x. Okay. Now, part A, you know that 10 to the power 3 is equal to 1000. So that means the cube root of 1000 is equal to 10. For the second part B, you see that negative 1000 is negative 10 to the power 3. So we can write down the cube root of negative 1000 is negative 10. And for part C, we see that negative 125 over 8, it is equal to negative 5 over 2 to the power 3. So we say the cube root of negative 125 over 8 is equal to negative 5 over 2. In question 1, you see that both are power 3, they are odd number. So when you take the cube root, you have only one answer. For question D, you have power 2. Power 2 is the square. So you will have 2 answers to get 144 by taking the square of the answer. Similarly, power 4 is an even number. If you will have 2 values that with a power 4 will equal to this 625. So you see 12 to power 2, that is the square of 12 is 144, but you know that when you have an even power, negative 12 is also have the same answer. So in this case, when the power is even, you have 2 roots. One is positive, one is negative. They have the same magnitude. The number is the same, but they are in opposite side. For 625, you can find it is equal to 5 to the power 4 and also negative 5 to the power 4. So you will get the 2 answers, 2 roots, the 2 fourth roots of 625 by 5 and negative 5. So make a conclusion about the class practice. One more questions. Question 2. For question 2, you will have that is 25 to the power 3, and then take the cube root. And the second one, you take the square root of 25 square. This one you will get the answer is just only 1 because it is a positive 1 root here. Okay, so it is an odd number, so there's only one answer. But how about that? When you're taking square root here, if you do not have a sign here, we assume we take the positive 1. So this one you will get it is equal to 5 on the numerator, and this one is the 5 also in the denominator. So 5 times 5 divided by 5, you will get 1. Similarly here, you will get the fourth root of 258. But if you want to take the positive, you will get the sign without the fourth root without the sign. Without sign means that it's positive. If you want to get the negative, you will add a negative sign before the symbol. So you will have a 4 for the actual symbol of this, and then negative 4 for this expression. So we have a conclusion that when n is odd, there's only one n root. When n is even, with a greater than 0, it is very important. There are 2 n roots. So how to get your answer by using your calculator? You will have the symbol in your calculator like this, but you must press the key sequence by the shift cap. Okay, this is an example. The key sequence of the fourth root of 16 is you press 4 first, and then press the shift cap, and then 16, and press execute, and you will get the answer. Because the calculator can give you only one answer, the other ones you may take the negative sign according to the even power of the index. Now, so we can define what's the meaning of a rational index. If you want to find a rational index, rational is a number which is two integer, one over the others in the fraction form. So we must first consider what is the meaning of a number power to a certain expression. In order to make it easy, the very important thing is that we must assume that a is positive. So we can calculate the answer clearly, because when you have a even power, if you taking the n, it will not exist. So according to the properties you learned it before, a to the power m times to the power n is equal to a to. I can replace the following by the m with a 1 over n. That means in this case we do not consider m and n are integer only. They can be a rational number. So when n is not 0, we can define the m is 1 over n. By putting n equal to 1 over n, we find that it is just equal to multiply the 1 over n with the n in the power, in the index. And this 1 over n times n, it is just equal to 1. A to the power 1 is just itself, because a to the power means that a multiply itself only 1 times. So the meaning of that one is like this. It is x to the power n is equal to a. So this is the x. So a to the power 1 over n, the meaning is the n root of a. The n root of a. Say x to the power n. Here a is just the a to the power 1 over n, and here. So we will get a to the power 1 over n is the nth root of a. Now, when you want to have a rational index not only in 1 over n, you want to have m over n as your index. You may first write down this a to the power 1 over n first, because this one m over n can be written down as 1 over n times m, and the m can be taken out by the properties of the index. It is just equal to a to the power 1 over n and then to the power m. By the symbol that we just take about the expressions, it is just equal to the n root of a and then power n. So a to the power n over m is like this. Similarly, if we assume that a is a positive number, the expression you can write down not only a to the power 1 over n to the power m, you can change this one first with a to the power m and then to the power 1 over n. According to this one, we will let this one expression with a power 1 over n, so it is just the n root of the expression of a_m. So finally, we have this definition. A to the power 1 over n is the n root of a, and a to the power n over n is the n root of the a to the power m, or we can say that is the n root and then power m. They are the same. Which one is better depend on the questions, so you may remember both of the presentation of like this. Now let's show you some example. Find the values of each of following. 49 to the power 1 over 2. It is just equal to the square root of 49, and this is 7. If you want to write down the part B, negative 125 to the power 2 over 3, you must first write down what is the number. Here, negative 125 is a negative answer, negative value. So if your power index is not suitable, so you will try to make this one the power 2 first. So here you insert the power 2 first to make sure that it will be positive, and then taking the index the rational index 1 over 3. Now the negative here, you will get this, it is the cube root of the answer on this expression. Now you can press your calculator to find the answer of this one is equal to 25. And I will teach you how to use the key sequence on the next example. The next one is 1 over x to the power negative 4 over 3. So we will write down this one, x is equal to 1x to the power negative 1 equal to the power negative 4 over 3. So first one, I will make this one power become positive because I can insert the negative sign inside. We get x to the power 4 over 3. Now we just have the x to the power 4 and then take the cube root. So you can press your calculator, you found is 16. Now let's look at exercise 1. When you have this one, root a, you will write down this one is just 2 root here, because we do not write down the 2 here. Here and here. So how to write down? So the first one, root a, is just a to the power 1 over 2, and the cube root of a is just a to the power 1 over 3, and the fifth root of a to the power 4 is the meaning of a to the power 4 and then power 1 over 5. So you insert this one to multiply with the 4, you will have a to the power 4 over 5. The next step is to refers to the expressions inside the bracket. The cube root of a is just a to the power 1 over 3 and then power 5, so you will get a to the power 5 over 3. Let's do the exercise. The first one, 64 to the power 1 over 2, is just square root 64. You can using the key sequence by pressing that 64 the power here and then using a bracket to make the expression 1 over 2 by using the key sequence 1 ABC 2 and close the bracket and press execute. Then you will get direct the answer 8. 27 to the power 1 over 3 is the cube root of 27. You can using the shift cap lock to do that, or you just using this one by pressing 27 to the power, this is the cap, and then bracket 1 ABC 3 and close the bracket, execute. And the next one is 256 to the power 1 over 4. We can type this like this. Similarly, when you have a negative number here, so you here it is an odd number, so negative number is acceptable here. So you press the negative sign, not the minus sign, is negative sign, and then press 1, and then the cap with the power 1 over 3. Then you press the execute, you get the answer is negative 1. And the 64 to the power negative 1, if you do not have your calculator, you will first make this negative sign become a positive sign with the reciprocal on the denominator. And then this one is the cube root of 64, and then you find it is just 4, so you get 1 over 4. But when you're doing that, you can direct press your calculator by 64 and then cap with the bracket negative sign 1 ABC 3 and then close the bracket and press execute. You will get the answer maybe 0.25 because the calculator may get you a decimal number. So if you want to have a in fraction, you will press the shift ABC to get the answer like 1 over 4. Similarly, for the question F, you will have first, if you do not have your calculator, you may change this one become 1 over 4 to the power 3 over 2. And then by the definition, this is just 4 to the power 3 and then taking the square root, but you can omit this 2. And you find that this is 4 to the power 3 is 64. By taking square root, you will get 8. So the answer is 1 over 8. But if you want to calculate directly, you will press the key sequence like this. Let's do some example. Simplify the following expressions. When you want to do the simplification, we better to make sure that the expression in the power must be positive. So we always have the sentence set giving the answer with positive index. The first one, you find that square root x is just x to the power 1 over 2. And the cube root of x is x to the power 1 over 3. And this is the 12th root of x squared, so that means it's the x squared and then power 1 over 12. So you have got this one. But this one you will get x to the power 2. The 2 can multiply with the 1 over 12. You can simplify like this. Now you find that there are 3 terms here, both are the same base, so then they can combine the power and add them together because the multiplication. And 1 over 2 plus 1 over 3 plus 1 over 6, it is just equal to 1. So you will get the answer is just x. Any problem about that? Okay. You may do this problem step by step. You cannot do it just give you the answer. The next one, you see that there's a more complicated, that it is a fraction and then with power. But don't worry about that, you may do it step by step. In this symbol, you will first make this one with the power of 1 over 3 first. Like this. And this one also, you see 2 and 16 are number. So in order to save time, you better change them with the same base. And you know that 16 is just equal to 2 to the power 4, so you change this as 2 to the power 4. Many students, when facing this kind of problem, will have some confusing, but you do it step by step with the bracket first, the first bracket, and then the second bracket. In the first bracket here, 1 over 3 can be multiplied to the index of these 3 terms. The 3 terms is 2, so you have the 2 to the power 1 over 3 here first, and then this 1 over 3 will be multiplied with this 2, you will get x to the power 2 over 3, and this 1 over 3 will multiply with 4 here, you will get 4 over 3. So you will get like this. Similarly, here 2 to the power 4, the 4 will be multiplied with the 2 over 3, so you get 8 over 3 here. And this power 2 will be multiplied with 2 over 3, you get 4 over 3 here. And the power 4 in the denominator also multiplied with 2 over 3. Don't missing any expressions inside the bracket. You will distribute this power to every individual terms in the expressions. Now after you get this one, then you find there are many bases. They are not the same, so you will group them together with the same base. Here 2 and 2 are the same base, so they can join it together. Because this is the multiplication here, so the power of these 2 can be added up. That means 2 to the power 1 over 3 plus the power of 8 over 3. For the x here is in the numerator, but this x is in the denominator. That means this is a division. That you learned that if you have the division, the power will be minus. So 2 over 3, the power of the numerator, minus the power of the denominator. And the last one is about the y. Here you see that in the numerator the y is power 4 over 3, and here is y, so you have the power 4 over 3 minus 4 over 3. And then it is a very simple way to calculate the answer on the power of each terms. You get power 3 here, you get power negative 2 here, you get power 0 here. Okay, I just at the beginning say that power 0 is very important. If you have a 0 here, this one represents 1. So don't just leave it away, okay? And then if you have a power 2 with a negative sign, so it will be go down to the denominator. And 2 to the power 3, if you want to give a number, 2 to the power 3 is x, so finally you will get 8 over x squared. In this example, you want to do it more carefully, do it step by step. When you want to break down the bracket, you must sure that the power of the outside will be inserted to each term inside the bracket. Let's do some exercise. The first one you want to find that is 1 over the cube root of a and then square of square, okay? The second one is the 1 over the fifth root of a to the power 3. And then part C, you have 2 terms, and then you want to find the answer of this. The first one, you see that you can have an expression for the denominator first. So the first one, you make sure that what is the expression meaning in the bracket. The cube root means that it is a to the power 1 over 3 and then power 2. And then you see that it is power 2, you will have a to the power 2 over 3 here. And then if this question doesn't ask you to have a positive index, if you have a positive index only, you will get the answer just in that at that stage. But now if you want to simplify, it is a to the power 2 negative 2 over 3. And then the next one is 1 over the fifth root of the a to the power 3. First, I make sure that the denominator is the a to the power 3 and then power 1 over 5. So by the properties of the index, it is a to the power 3 over 5, and it is equal to a to the power negative 3 over 5 in this part. For the part C, the numerator will be written down as a to the power over 3, and the denominator can be written as, because negative a squared is just the a squared, so make sure that it is positive first. A squared must be positive, and this one it will be 1 to and then power 1 over 2. After you get this one, then you see that this 2 and 1 over 2 multiply is equal to 1, so the denominator is the a to the power 1. And because there are two terms, so these two terms are with the same base a, so the power can be 1 minus the other, so you get the expression here. Let's look at another example. You want to simplify the expression of the followings, where n is a rational number. In this problem, you see that there are many indexes, but they are in different bases. In order to solve this kind of problem, you must first make the same base. Here, 3 and 2 are the small number in these expressions, so we try to make the other number, which is based on this 3 and 2. And 9 is just the 3 to the power 2, and 4 is just the 2 to the power 2, so we may replace this 9 and 4 by the other terms. So we first make the 9 is equal to 3 to the power 2, and then the 4 is 2 to the power 2. By the index properties, this one will get the power of 4 minus 2n, and this one will get 2 minus 2n, just like this one. Now the base, these three are the same base, so you can add them together for the numerator. And for the denominator, they have both a base 2, so you can add them in the power. So after you will get both of them power of 3 minus n. This one, don't say that this 3 minus n can be cancelled. It is the properties. If you have a b over to the power n over a to the power n, it is just b over a and then power n, so it can be simplified like this. But if you want to make the other ones, you can change the denominator to the numerator. This one will be taking negative sign. You will get negative 3 plus n, which is equal to n minus 3. You can using this one or that one as your answer. The exercise 4 here, you also have the question with different bases, but you see that 4, 16 and 64, you can make them as the base of 4. So the questions here, you must first change the 16 as 4 to the power something, and 64 to the power, also 4 to the power something. 16 is equal to 4 squared, and 64 is equal to 4 to the power 3. So you can simplify this one like this, and then break down the brackets accordingly. You will get 4 to the power 2n here, and 4 to the power negative 3n here. Now 4, 4, 4 are both the same, so that means the power can be combined. If it is a multiplication, you will add them together. But if it is a division, you will minus. So we have the 4 to the power 2n plus 2n, and then minus negative 3n, and you will get the answer 4 to the power 7n. Here you see it can be the answer, but sometimes the question may ask you to make as simple as you can. So 4 can also be written down as 2 to the power 2. And then by the properties of the index, it is 2 to the power 14n. Example 5, you want to simplify another one. Here also you see that there are 4 numbers, they are different. The smaller is the 2 and 3, so the 9 and 4 can be changed. It is the base of power 2, the expression of power 2 and power 3. So first make the 9 is the power 3 to the power 2, and the 4 is 2 to the power 2. With the similar argument, the first one will become 3 to the power 2n, and the bottom, the denominator here is 2 to the power 2n. Here you see that the same power 3 is here. They are divided, so the power is 1 minus the others. And also this one, if you want to do, you can minus the power in the denominator. So the 2n minus negative 3n here. Oh, sorry, there's missing a minus sign here. So you may change it. And finally, we get it is 3 to the power 3n over 2 to the power 5n. I'm missing minus sign, so you may take action here, okay? So the answer is just like this. And finally, in this 7a, I want to give you an extra example, which is solving an equation. Just like this example. Without using calculator, solve the equation. It is called the index equation. Why? Because the unknowns is in the index. So if you want to calculate this one, this is 9 and 27, they are not the same. So you may first make the same base. You copy the questions and then write 9 and 27. They can both express as the 3 to the power something. So on the left hand side, 9 is 3 to the power 2 and then power x. And then on the right hand side, you must first make sure that 1 over is just the meaning of the power of negative 1. And 27 is just equal to 3 to the power 3. And now, on the left hand side, by the properties, 3 to the power 2 and then power x is just 3 to the power 2x. And here, this expression is 3 to the power 3 over 4. With the minus sign, you will get this. After you compare the left hand side and right hand side, both are base 3. So the power must be equal. So the answer comes out by looking at the index. 2x is equal to negative 3 over 4. And then press calculate x is equal to negative 3 over 8. Let's try two questions. 7 to the power x is equal to 1 over the cube root of 49. And because 49 is just 7 to the power 2, so first we write it's a 7 power 2, and 1 over means that it is the negative power. So I can write down like this, and this one will become 7 to the power 2 over 3. So we will get the minus side, which is 7 to the power negative 2 over 3. So 7 and 7 are the same, so the power must be the same. So it's negative 2 over 3. The last questions in this section. Also, you want to solve this one. 2 over 3 and then to the power x. It is not necessary to break it down, because you see that 2 over 3 can be expressed, the 4 over 9 can be expressed as 2 over 3. So we will write this question as like this. 4 over 9 is 2 over 3 and then power 2. And then you take the fourth root of this expression, and 1 over will be the negative 1 power. So by simplify, the left hand side is just 2 over 3 to the power x, and the right hand side is 2 over 3 to the power. Here is this 2 over 4, and then times the negative 1 is negative 1 over 2. So by comparison, the x is equal to negative 1 over 2. This is the end of the chapter 7a. Please do the exercise 7a that I assigned on the website.